This is a problem of Anova, analysis of variance. And here the question is, following table gives the yields of three varieties. These are the three varieties. Okay. And these are the yields which are the results of different treatments. Okay. Here the question is, perform an analysis of variance on this data. So first we want to find the value of t. T is the sum of all observations in the rows and columns. So we want to find the sum of all these values. So for that, we want to name the rows as first row as x1, second row as x2, and third row as x3. Okay. Then we want to find the sum of all rows, that is x1, x2, and x3. Okay. Here x1 elements are 30, 27, 42. 30, 27, 42. And here the sum is 99. Okay, so the sum of x1 is 99. Then next x2. x2 is 51, 47, 37, 48, and 42. And the sum here is 225. 225. Okay. And the sum of third row, it is 44, 35, 41, and 36. And here the sum is 156. Okay, 156. So now we find the sum of three rows, x1, x2, x3. As a first step, we want to find the value of t. So what is value of t? Sum of all observations in the rows and columns. So t is equal to this 99 plus 225 plus 156. Okay, and here the total is 480. So next we want to find the value of SST. What is SST? SST is the sum of squares of all observations minus t square by n. Sum of squares of all observations, that is 30 square plus 27 square plus 42 square plus 51 square plus 47 square plus 37 square plus 48 square plus 42 square plus 44 square plus 35 squares plus 41 square plus 36 square. Okay. Sum of the squares of all these observations. Okay. That is SST. SST is equal to the value of sum of squares of all these observations is 19778 minus t square by n. What is t square by n? Here t is 480. So t square by n is equal to 480 square by n. N is the total number of these elements. That is, here n is 12. Okay. There are 12 elements here. So n is 12. So here SST is sum of squares of all observations minus this t square by n. Value is 19,200. Okay. So here minus 19,200. And here the value of SST is 578. Okay. The value of SST is 578. Next, we want to find SSC. And what is SSC? Sigma x1 square by n1 plus sigma x2 square by n2 plus sigma x3 square by n3. Okay. SSC. SSC. Sigma x1 square, that is 99 square, plus sigma x2 square 225 square plus 156 square. Okay, by n1. Okay, this by n1, that is number of observations in the first row, 3. By n2, here 5. And in third row there are 4 items. Okay, minus these values are in a bracket, minus t square by n. Here this value 19,200. Okay, and the final answer here is 276. Okay, you can calculate these values on calculator. Okay, so the value of SSC is 276. Next, we want to find SSE. Okay, SSE. How we can find SSE? SSE is SST minus SSC. SST minus SSC. That is 578. 578 minus 276. And the answer is 302. 302. Okay. Then next we want to find MSC and MSC. Okay. What is MSC? MSC. MSC is equal to SSC by K minus 1. SSC, this value, by K minus 1. What is K? K is the number of rows. Here K is equal to 3. Okay. K is equal to 3. So MSC is equal to 276 by 2. K minus 1. 3 minus 1. 2. Okay. 276 by 2. And the answer is 138. 138. Okay. Then we want to find MSE. Okay, MSE. How we can find MSE? That is SSE by N minus K. Here N, we know N is equal to 12. Okay. So N minus K, 12 minus 3, it is 9. Okay. So SSE is 302. So MSE is equal to 302 by 9. That is N minus K. N minus K. That is 9. And here the answer is 33.5. 33.55. That's the value of MSE. Okay. At last, we want to find the F ratio. F ratio. F ratio is MSC by MSE. MSC by MSE. Okay, so 138 by 33.55. Okay, and here the answer is 4.11. Okay, here we can take alpha is equal to 0.05. We can take alpha. Alpha is equal to 0.05. Then degrees of freedom. DF, degrees of freedom. Here the degrees of freedom is K minus 1 comma N minus K. K minus 1 N minus K. That is K minus 1 3 minus 1 2 comma N minus K 12 minus 3. That is 9. Okay, so degrees of freedom is 2 comma 9 and alpha is 0.05. So we can find the F alpha, value of F alpha from the statistical table, and that value is F alpha is equal to 4.26. 4.26. 4.26. That is the value of F alpha. It can be taken from statistical table. Okay. Okay. Here we apply the condition of rejection. That is F greater than F alpha. F greater than F alpha. Here the value of F is 4.11. 4.11 greater than F alpha 4.26. 4.26. So this is a wrong statement. 4.11 is not greater than 4.26. Okay, so here we accept the H0. H0, what is H0? Okay, we actually not describe what is H0 and H1. Here H0 is alpha 1 is equal to alpha 2 is equal to alpha 3. Then H1 is equal to alpha 1 not equal to alpha 2 not equal to alpha 3. So here F not greater than F alpha. So we can accept H0. We can accept H0, that is alpha 1 is equal to alpha 2 is equal to alpha 3. So we can conclude that treatments have the same effect. All treatments have same effect in the yields. Okay. As a final step, we want to draw a Anova table. Okay. How we can make an Anova table? So here the value is SSE and here SSE. What is SSE? 276. Then SSE 302. And last SST. SST is 570. 570. Here the total. Okay. Here the degrees of freedom. That is k minus 1, n minus k. K minus 1 is 2, n minus k is 9. Here mean square. MSE, then MSE. MSE is 138. MSE is 3.55. Okay, here n minus 1. That is, this is k minus 1, this is n minus k. Here n minus 1. That is 11. Okay, so this is the ANOVA table of this problem. Okay, thank you.